Hi everybody, this is your video with practice problems for algebraic proofs. This one hopefully will be pretty short because I've only got two practice problems for you here, two practice proofs. So let's go ahead and take a look at these. So in this first one, there's certain things missing. Some of the blanks are statements and others are reasons, so we're going to fill in what's missing, okay? So A is hopefully pretty easy. Remember, when you're doing an algebraic proof, the very first statement is always exactly what is given to you. So you can copy exactly what is written up here into your proof. So 2x divided by 4 equals 5x plus 8 divided by 2. Okay, that's all you have to write there. And remember that your reason is always given there, okay? So for step B, or for step 2, number B, we have the statement and they want to know what the reason is. So remember, you're always asking yourself, what did I do to go from step 1 to step 2? What changed? How did I arrive at step 2? So what looks like is different in step 2 is there's no more fractions, there's no more denominators. So what it looks like they did is, in order to cancel out this 4 down here at the bottom, that they did times 4 on both sides, right? Times 4 times 4, because that would cancel out this 4 here, and it would cancel this 2 out, and then you'd be left with a 2 at the top, okay? So because I multiplied by 4 on both sides, right? I multiplied by 4 on both sides, I multiplied by the same number. This is the multiplication property. And you don't have to write the whole thing out. Like, you don't have to write multiplication property of equality. You can just write multiplication prop. Like, we'll know what that means. All right? Okay, so then let's look at step 3 here. So the statement is missing, but I know that the reason is the distributive property, meaning I arrived at step 3 using the distributive property. So that's what I'm going to do to my equation. Okay, so I'm going to take my 2 here and I'm going to distribute it across all of the terms in my parentheses. So I have 2x on the left side of the equal sign, that stays the same, equals 5x times 2 is 10x, and then plus 2 times 8 is 16. Okay, so that's the statement for step 3 and for number C right there. Okay, so now I'm going to go ahead and write that in right here just so I can see it a little bit easier. Okay, so now I have to ask myself again, okay, to figure out the reason for step 4, what changed from step 3 to step 4? What did they do? How did I arrive at step 4? So what changed was this 2x now is over here, right? And we did that by subtracting 2x. We did minus 2x on both sides. So since we're subtracting the same thing on both sides of the equal sign, that is the subtraction property. All right? Okay, then if I look at statement 5, they said that the reason was the subtraction property. So I know I'm going to subtract something, but I don't know exactly what I'm going to subtract. Do I subtract the 8 or the 8x, or do I subtract the 16? Now, if you look one step further down at step 6, you'll notice that the x value is on the right and the number is on the left. So that makes me think I need to subtract 16 from both sides, right? I want to move my number over to the right. Okay, so my new equation then, if I do minus 16 and minus 16 on both sides, I end up with my new equation is negative 16 equals 8x. Okay, so that's what my blank is for E. Negative 16 equals 8x. Okay, all right, then as I'm going from step 5 to step 6, I want to ask myself, how did I arrive at step 6? What changed? How did I get there? And how I got there was dividing by 8 on both sides. So my reason for step 6 is division property. Okay, so that's my reason for step 6. And then my very last one is what happened, right? They use the symmetric property. Okay, remember that your last statement must match your prove statement exactly. So you just write whatever comes after the word prove, which is x equals -2. And that fits, right? Because all that changed here is we switched the order of these two, right? We switched where they were. Oh, I'm really struggling with my arrows here. We just switched which one was on the left side of the equal sign and which one was on the right side of the equal sign. And that's exactly what the symmetric property is. All right, y'all. So I'm going to clear my screen up here. But what I want you all to do is try out number 2. Okay, you don't have to write these arrows and what I do on the side. I just write it there to help you see what's happening as you learn these proofs. Okay, right? It essentially shows the work that you do, so that you know whatever's here, whatever I write on the side, that's where the reason is headed for that next statement. So you can do that if you want to, if it's a tool that you think will help you. Especially as you're learning, but you may not need it as you get better at doing these proofs. So in this one, I want to see if you can do this one on your own. So start with the given equation, go ahead and solve it, and then see if you can write your reasons on the side. And then don't forget to fill in your proof statement at the top. All right. So give this one a try on your own. I'll see you back here in just a second, and we'll see how you did. You may not need all of the lines. I gave you, I think, too many lines, so you probably won't use them all. All right, so try it out, and let's see how you guys do with this one. All right, everybody. So here is your filled in proof. Like I said, I gave you too many lines. Sorry about that. But let's see how you did. So check yours against mine. So your very first statement should always match exactly what is given to you. So I just typed that again. 5 parentheses x minus 2 equals 2x minus 4. All right, so that's my first step, step 1. Step 1, and the reason for that first step is always given. Okay, then for step 2, I have to ask myself, okay, what did I do? Right? And what I did is I used the distributive property. That's how I arrived at step 2. So that's why distributive property is my reason for step 2. Then to get to statement 3, what changed? How did I arrive there? I subtracted 2x from both sides, minus 2x. So since I subtracted same thing on both sides to get to my new step, that's the subtraction property. For step 4, in order to go from step 3 to step 4, I added 10 to both sides, right? So since I added the same number to both sides, that's how I arrived at step 4. The reason was the addition property. And then my very last step here, in order to go from step 4 to step 5, I divided by 3 on both sides. So that's why the reason for step 5 is the division property, because that's how I got there. And then my proof statement now is exactly whatever my last statement is, which is x equals 2. All right. Now, you may have done it in a different order than me. You may have subtracted 4 or added 4 to both sides first, and then did the subtraction of the x's. Like, you may have dealt with the numbers before you dealt with the letters. Either way is fine. So the cool thing about doing geometric proofs is that it doesn't really matter what order you go in necessarily, as long as the order that you use is logical, right? And you don't skip any logical steps, right? Like, you don't try to, do you all remember, hopefully, like when you were kids, did you walk up and down, like when you walked up and down steps, did you try to like stretch your legs really far and skip steps? You can't do that on a geometric proof. You have to do the steps one at a time, right? Because everything that comes before that statement, the one that the newest one that you're writing, has to support what's coming next, right? So you can't skip any steps, right? So you have to think about what is the next logical step. Um, a lot of the times you can do proofs more than one way. You can get from step 1 to step 5 using a couple different paths. As long as your path is logical and you can support it with reasons, then you can have lots of different answers for proofs, which is actually kind of neat. It's one of the things that I like about math, is that people can do problems lots of different ways, and because of the way that math works, you still end up with the same answer as long as you're using logical thought processes, which is kind of neat. All right, so that's all I've got for you all in this algebraic proofs practice video, and I will see you in the next one for geometric proofs. Bye, everyone.